in. And now it's recording from the right channel. How that is correct. All right. Okay, so how are you guys doing today? Looks like we are finally having a little bit more room in the classroom. I still have I'm still getting email messages from students from another college and ask, well, do you still have room in your class? I want to be able to add to your class. No, not really, because there are still people in this classroom right now who are waiting to get into the class. All right. Did anyone go to YouTube to check out the previous lecture? Some people did. Did it work out okay? The audio works out? Okay. And it's a useful feature, because if not for anything else, you can just go there and so I'm just going to show you guys how to get there. Just look for some props. That's the name of my channel. Go to my channel. It's not exactly my channel. I'm sharing that with a whole bunch of other professors, and that's why the channel name is Some Profs instead of Professor Tech or something like that. So you click videos, which is the best way to do it because it sorts the videos by date. The last one that I upload would be the first one that is listed, and today is the 3rd. So this is our last class, and there are 10 views to the video. And I personally just like it because I can fast forward all the way to the end, or close to the end. And I can figure out what I was talking about last time. So that's a good tool for review purposes. Are there any questions about how to get to YouTube and how to study for this class? Resources that are available? No. Has anyone started to read the material on the website? Okay, very good. Any questions about that, as you read the material? Good. Okay. So the first thing I want to do is to give you a homework assignment that is due in a week. So I'm pretty sure I give you something that you normally would take 2 weeks to do, but I'm only giving you 1 week because I think you guys can do it. So before you guys start to think, oh no, why would you do something like that? you know which homework assignment already. All right, so let's go ahead and take a look at the homework assignment. Go to this class. And once you get to the class, you will probably see the same thing on your page. On the right-hand side, there's a tab called upcoming events. What that does is it will show you the homework assignments or quizzes that are going to be popping up in, I think, 2 weeks or so. So that's really one good way to find out whether you have any outstanding homework assignments. This one also has a due date listed. It is on Tuesday, September 10th, which is 1 week from today, at 7 p.m. So that means you have to turn it in before the class starts. You can also see from the calendar that the 10th is highlighted. When you hover the pointer over it, it will also tell you that you have a homework assignment due on that day. Okay, so the first thing we want to do today is to take a look at the homework assignment and figure out what you have to do in order to get these points. This one is a really low point value homework assignment. There's not a whole lot of points associated with it, because the whole point of this homework assignment is to make sure that we all have the right infrastructure, the software applications installed in order to proceed with this class. You will have to install LibreOffice for this particular class. LibreOffice is an open source Office suite application. It is free because it's open source. It is free as in freedom, and free also in free beer, which means you don't have to pay anything to get it. There are 2 ways to install OpenOffice or LibreOffice. The first one is to go to LibreOffice.org and install it permanently onto a machine. Let me just go to that website and show you what it looks like. So you go to LibreOffice.org, not .com, and you will see something like this. Here is a big button, labeled Download LibreOffice Now. So click that one. And right now, because it is aware of my operating system, it tells me that it's going to download the installer for this particular operating system, which is Linux. If you go when you're using Windows, it will give you the installer in Windows instead. So this is one way to do it. But if you do it this way, you have to do it to every machine that you think you'll be using for homework assignments, which is kind of cumbersome. It's free, but you still have to go through this process and do it to multiple machines. So that's one way to do it. The other way to do it is to go to portableapps.com. So portableapps.com. So this time it is a .com. And this website has a lot of portable applications. Each portable app is an open source application, which means it is also licensed using one of the open source licenses. You can install it on as many machines as you want and as many times as you want. You don't have to pay anything. It is definitely legal. And then from here, you go to Get Apps. And under here, you have you can see a directory, portable app directory right here. There are different types of software available on this website. LibreOffice belongs to an Office suite, so you click Office. And under Office, you have these particular applications. You scroll down to LibreOffice, Office Suites, and then you get LibreOffice Portable. LibreOffice and OpenOffice are closely related. OpenOffice was an Oracle product up to a certain point until the entire team left Oracle and then it became LibreOffice. So over here you can download 4.1.1 for Windows, and portable apps only work on Windows platforms. If you have a Mac, you have to install it onto your Mac. You cannot use the portable version. So you download this and then you install it on, not a machine. This time you can install it onto a thumb drive. Okay? And that's the difference between this approach and the previous one. So I'm just going to get my prop here. Okay, so let's say this is my thumb drive. I can install LibreOffice Portable onto my thumb drive. The nice thing is I can now take this thumb drive to any machine running Windows, plug it in, and be able to use LibreOffice without having to install it first on that machine. Does everybody understand why there's a certain advantage of doing it this way? So you can go to the library, for instance, and plug it in and be able to use LibreOffice in the library, even though LibreOffice may not be installed on those particular machines. Okay? Any questions? Okay. While you are at it, you can also look at the catalog and basically just explore what other. Okay, let me just try to find the Get Apps here. So you can go through this directory or catalog of available applications that you can also install in the same fashion. Firefox is on this list. Now, why would you install Firefox on a thumb drive when you can run Firefox on a native machine that is natively installed already? What about your bookmarks? What about your plugins and stuff like that?
You might not have permissions to install Firefox, and you might be trying to use something that works best on Firefox.
And then plus your plugins, even if Firefox is installed on another machine, the plugins that you have installed at home may not be installed on the other machine. But when you run it from a thumb drive, everything is on the thumb drive, including your bookmarks, your passwords, and the plugins. So that definitely is one advantage of using portable app, or the portable app version of existing software that you use. Any questions about this? No questions? Okay. If there are no questions, I'm going back to the homework assignment. So step 1 is just to install LibreOffice. Step 2 is to customize LibreOffice. So what you do is you go to the Tools menu. Under that, you go to Options. Under Options, you will go to, this is actually the first thing, let me show you what I mean by that. So I go to LibreOffice here. As soon as you start LibreOffice, you can do it. It doesn't matter which application you start, the spreadsheet, the word processor, it doesn't matter which one. Or in this case, I'm not even starting a particular document. You go to Tools, you go to Options, and under LibreOffice and User Data, this is where you have to put in something. You have to put in your first name and your last name. That's all I need. And then you click OK, and that will configure LibreOffice. Every time you edit a document, it will say that you are the person who last modified the document. Okay, and I need that. Okay, I need that in your homework assignment. All right. Getting back to the homework assignment. Step 3, the actual homework assignment. Unfortunately, I chose a theme that doesn't show the hyperlinks. The here is actually a hyperlink. So what you want to do is to right-click it. Depending on the browser, you can probably click it too, depending on the browser. But I usually just right-click and choose Save Link As. So that way, I get a choice, and I can actually remember where I saved the document. So this time, I save it over at the Downloads folder. So I save it. And once it's saved, I'm going to open it. And this is the document. I'm going to zoom in to let you guys see the actual document itself. It's a spreadsheet. It's not a word processing document. It's a spreadsheet. So let's go back to the document itself, the homework assignment description. Okay. Enter your information in column B next to the questions. All right. Column B is here, and here are the questions. So you just type your first name here, last name here, and your student ID over here. You're almost done. See, I told you it will take more than 2 weeks to do it. Remember to save it first. Okay, before doing anything else, save it. And I would even go to File and go to Properties, and just to make sure that it should still be created by me, because you did not create the document from scratch. You downloaded the document and then you changed it, right? But it should also indicate that you modified the document. And that's why we need to go through the first step, is to configure LibreOffice to have your name. So this way, it will reflect that you are the person who last modified the document. Okay, so that's important. Double check everything. So it's all working. Before I upload the document, I would probably close it first, just to make sure that this is the latest version with all the changes. Then you save the file, close LibreOffice or just the document, and then upload the file using the interface below this description. It won't show me at this point because I don't really have, I was signed in as a professor and not a student, and that's why it doesn't show me here. So are there any questions about the homework assignment? No questions? All right. If anyone has any question about the homework assignment, we still have Thursday to ask questions. So if you are kind of stuck in one of the steps, let me know on Thursday, and then we can go over that. Think you can get it done by next Thursday? Next Tuesday, sorry, next Tuesday. You have 1 week to do it. I can see someone, actually doing it right now. It's like, okay, I think I can beat TAC. By the time this screen disappears, it'll be turned in already. All right. So that part is done. We are already started on topic 2. So I'm thinking most people should really kind of read it, even if you kind of know this stuff already. It doesn't hurt to kind of just go over that, read it one more time, and just double check, make sure you understand everything. And we were talking about conditional statements already, so I'm going to open up that module, and we'll continue to talk about this.
Do you need a permission?
No.
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 Dang, it's class full.
full.
Class is beyond full. Yeah.
All right, thank you.
Mm-hmm. All right. So, getting back to conditional statements. Okay. So a conditional statement, if you remember from last time, is a way for you to choose one of two alternative paths. Okay. So you have two ways of proceeding, and in order to determine which way to go, what do we use to determine which way to go?
True or false statement?
A true or false expression or condition. Okay, but you're right. So we need something that evaluates to either a value of true or a value of false. If it evaluates to a value of true, we go one way, and if it evaluates to a value of false, we go the other way. Okay. So what I'll do today is I'm going to change the way I present the material. The way it's presented here is fine. I present the basics first, and I present an example. But this time, I think I'll just kind of switch the order a little bit. I present the problem, we try to solve the problem, and in the process of solving the problem, we'll talk about the construct, okay? Which we have talked about already, but I want to make it kind of more applied. Do you want to take a seat up here? And we have, empty seats up front here. All right, so what we want to do, I'm going to use a kind of like a notepad thing, so I can use it for kind of like my whiteboard. If I use the actual whiteboard, it won't be captured by the screen capture. If I do it like this, it will be captured by the screen capture. So the problem is quite simple, and for those of you who read the notes already, you already know the answer. But I'm going to present it this way, so just so that we can kind of relate it, but in a different way. Okay, so the problem, okay, so I would say not a problem, but we want to do this. Okay, given two variables x and y, find the maximum and store it in variable z. So this is what I want to do. I want to write an algorithm so the algorithm can solve this problem. It will be given two variables. Out of the two, find the maximum of the two, and then store the value, the maximum value, in variable z. Okay, so before conditional statements, we already have several constructs or concepts that we have talked about. Let's kind of review the concepts that we have talked about prior to conditional statements. We have talked about the concept of variables. A variable is a construct to store a value. It has a name, so we can just say, okay, this particular variable, and we can store values into it, and we can update the values of a variable. What kind of statement can update the value of a variable?
Assignment.
An assignment statement, okay? In this class, an assignment is a statement, but in C, it's actually an expression. But in this class, we'll just call that a statement. Okay, so an assignment statement is one that you can use to update a variable. Okay, assignment statement. And the last one is kind of implied. I did not really quite, name it. It's the concept of a sequence. When you write an algorithm, it executes in the same order that you specify, from top to bottom. Okay, so we execute an algorithm in the same way that we read English and most Western languages. Okay, and that's a sequence. So we cannot just randomly pick an operation out of a list to execute. We have to execute those operations in the sequence or in the order specified. So those are the three things that we already know prior to conditional statements. So let's see if we can solve this problem using only these particular constructs. Okay, variables, no problem. I have identified three variables. One is x, one is y, and one is z. No problem. Assignment statement. I know assignment statements will come in handy because sometimes x is the larger of the two, and I want z to get the value of x. Other times, I know that y is the larger one, and I want z to get the value of y, or use y to update the value of z. Not a problem. Sequence, kind of a problem here, because no matter how I order these two assignment statements, only the last one is going to stick. And it's not going to solve all cases because sometimes x is larger than y and other times y can be larger than x. I did not tell you there are any particular constraints regarding the values of x and y. So in order to write an algorithm that can solve all cases of all values of x and y, I need something more than this. Okay? If I were to do this using a picture, okay, so let me just try to draw a picture on the fly here. This is what I did in the morning class too. So for those of you who want to get, just if you're having trouble with my way of explaining it in the PM class, you can always check out the lecture recording from the morning class as well, because we cover the same material, but sometimes I do it in a slightly different way, and maybe that slightly different way is a better way from your perspective. Right, so I'm going to draw a really crude picture here, okay? And I'm going to start with something like this. I know sometimes I want z to get the value of x. And I know other times I want z to get the value of y. Okay, so these two are alternatives, okay? Sometimes I want to use one, and sometimes I want to use the other statement. Okay. That means if I want to draw a picture as a trail map, the trail map would kind of look like this. Okay. Not too bad, huh? Okay. And just okay. So this is a really crude picture of a trail map. You always come in from the north, you always go south, and at that junction, yep, go ahead.
I was curious about the signs, the symbols that you use with the less than and the minus sign.
That is an approximation of the assignment symbol, the left arrow.
Right, so it's not, can it also be viewed as less than or equals to, or?
No, because less than or equal to uses less than and then the equal symbol and not a minus.
And so this, and can you use just the equal sign as well? Or?
No, it has to be a dash. If you use an equal, then it can be interpreted as less than or equal to.
Right.
Yeah, but this is a dash, so it's not, it cannot be interpreted as a less than or equal to. I can allow flexibility as long as there's no ambiguity. But if there is an ambiguous case, like it can be interpreted in either way, then you have to make it clear. Okay. All right, so we have two ways to proceed. Okay, we can either go this way and make z the same as x, or we can go this way, and make z the same as y. So these are the two ways to do it. Whenever you have a choice to go in two different directions in programming, or at least the programming that we know at this point, you have to make a choice because you cannot on both sides at the same time. You can only choose one way to proceed. In order to make a choice, what we'll do is we'll ask a question. And the field really doesn't look right here. So let me just change and get rid of the blue color, which is the field color. Here we go. It's just a rectangle now. So what we want to do is we want to ask a question before we have to split the path, and say, well, depending on the answer to this question, we go this way or the other way. Okay? What do you think is a good question to ask here? What about this? X is greater than y, and it's a question mark, which means I'm asking the question, is it true or is it false that x is greater than y? Do you think that question or the answer to that question might be able to guide us to the right path? Okay. All right. So we'll just present the choice here. This is the question. How should I label this particular path, the path that is going to the left-hand side? True. True. Okay. When the answer to the question is true, we want to follow this path, and if the answer to the question is false, we want to follow the other path. All right, so this is a conditional statement, or otherwise also called a branch statement. because we come in, there's only one entry point and there's one exit point as well in this particular map. When we get in, we have a question to answer first. Depending on the answer to the question, we choose one of the two ways to proceed. But whichever way you choose, you have to follow that path all the way through, and then the two paths will merge, and then the statement only has one exit point. Are we doing okay so far with this pictorial representation? Yes?
Just again, just so clear, z equals x in the left side, on the left side.
Z gets the value of x, which is not the same as z equals x.
Okay, I'm with you now.
Z equals x is stating something that's either true or false. Z gets the value of x is specifying an operation to update x, to update z so it has the value of x. So those two are not really exactly interchangeable. I think you understand that concept. I just want to make it clear. Yep.
So is it like the symbol that you were using last time with the 2 dashes and the
2 dashes.
well, it's like an arrow.
Yeah, it is an arrow. This is an approximation of that symbol.
Okay. So
I just don't have an easy way to enter the left arrow here.
Right.
Yep. Mm-hmm.
So essentially, z is a temporary function for the x's value until changed.
Say again?
My question was, z is just a temporary function for x's value because it could just change whenever.
Z is the maximum of the two. Remember the original question? Yeah, the original question, or what you want to do, is this. You are given two variables, x and y. So those two variables are given to you with some values inside. Your task is to find the maximum and then store that maximum in z. So z should be the maximum of the two when the algorithm is completed. Yep.
What if x and y are exactly the same?
Well, let's figure it out. Okay, let's look at the path and see what it does. Okay, so let's just make this a little bit more fun.
Beautiful.
And we'll group it so I can drag it around. Okay, so here you are at the entry point of the entire algorithm. Okay, this is the entire thing. So you're at this point, and then you have as much as I want to make this guy pop up with question marks in his head, representing I'm confused which way I should go. That may be a little overboard. So you're at this point, and then you have to choose one or the other way. Okay, this is the question that you have to answer. Okay, and you said that what if x and y are the same, right? If x and y are the same, x is greater than y is true or false?
False.
False. Okay, so if the answer to the question is false, then this is what you would do. And you'll be on this branch. In other words, you'll be copying the value of y to z. But remember, the precondition that you mentioned is x equals y to begin with. So whichever one you pick to update z is going to be okay. But this is the path it's going to take. Okay? And after this is done, then you have to merge the two paths and exit the conditional statement.
But if they're equal, how would it go to z? If the question is to make one of the other max.
Because it's x is greater, it is x greater than y. If it's a question of maximums, then it doesn't matter. These are both the
Right,
same.
but the original question is set whichever is the max to z. If they're equal, how do you pick a max?
If they're equal, they're both maximum and minimum at the same time.
But if it's false, it's taken both. Okay, so you're saying it's taken both.
Yeah, because if they're equal, then it doesn't matter which way you go. But in this particular case, it does go one way because of the way we asked the question. If I change the question to x is greater than or equal to y, then it would have chosen the other path. It would still be correct because x and y are exactly the same, so it doesn't matter which one you use to update z. Yep. Oh, okay, I thought you had a question. All right, so this is the representation in a graphical form And I think last time we didn't really have too much time to talk about this. So this is good. I'm going to shrink the picture a little bit and put it on the side. And then we'll use a little notepad here, because this time I'm going to present exactly the same logic, but in pseudocode. Okay? Question?
Maybe this may be killing dead horse, but during runtime,
Mm-hmm.
does it still check the z and the x if say you're trying to look for it to be false? Does when you're will it still check against the z and the x on the left side? In
It
other
will
words,
not
to
go.
like throw
It
like
won't. It won't
runtime?
go there. So that statement does not execute.
Okay.
Yeah. If x equals y, is the precondition, then it always goes to the right-hand side. The other path is basically left not executed. It won't be visited. Okay. That will be clear when we trace the algorithms, which is something that we'll do next. Okay. But before we do that, I want to present the actual pseudocode representing exactly the same logic. So it will say if x is greater than or equal to y, then z gets the value of x, else z gets the value of y, and if. So when you look at this picture, it is representing the same logic as this pseudocode here. It's kind of looking at the picture, sideways, because the two branches are no longer, side by side. Instead, we have the then branch before the else, and then the else branch after the else. Are we doing okay so far with the representation? I just want to kind of clarify the representation just a little bit more before we proceed to the next topic. This part obviously is the condition of the conditional statement, which is the same thing as the question that you have to answer when you have a conditional statement, when you have a branch. This portion, yep, go ahead.
Does it matter if the types are different?
Does it matter
Like the type of variable, x, y,
the
z?
type of variable? That's a good question, and I have to format the answer appropriately, because when you mention type, it also can imply class in object-oriented programming. Whatever you specify between x and y, the comparison has to make sense. In other words, greater than has to be defined. Now, you might think, well, but how can it not make sense? How can greater than not make sense when you're comparing two variables? Numbers makes perfect sense. What about complex numbers?
Exactly.
Okay? So if x and y are complex numbers, then there's no operator anymore for a comparison.
I meant like simply like 2, like the number 2 and then 2.13.
Okay.
You know what I mean? Like,
If they're both numerical, then you can still compare.
yeah, like say x equals 2, y equals 2.45, z equals 2.76, let's say. So
In this
if we're
case,
comparing,
the value of z does not matter, because z is going to be overwritten by
Yeah.
x or y.
yeah, so let's say 2.13 and 2.45, and then we'll compare it to z as defined as a natural number where it's 2. In this case, x still is superior to z, but when you, x is superior to y,
Mhm.
but they're both the same in the sense that they're 2. Does that make sense?
Okay, for the purpose of this discussion, let's assume x, y, and z, they all have the same type.
Yeah.
So that way, you can always store the actual maximum of the two. All right, that's a good question, but it does bring out, a big can of worms, so, we'll just kind of stop it at this point. All right, so this is the representation of that as a picture. For those of you who read the notes before the class, I hope this is not boring you to death, because this is all in the notes. It's just that I presented it in a slightly different way. So let's go switch back into the notes just so I can point out what I'm talking about. See this algorithm here? And see this picture here? So I guess someone was bored. That kind of answered my question. Were you bored? All right. Okay, so that's a very simple conditional statement, and conditional statements are extremely useful. As simple as they are extremely useful, because there are programming languages out there that does not have a concept of a loop, okay, for repetition. So they would combine the concept of a conditional statement with subroutines, which we'll talk about like halfway through the semester, in order to do what we consider as loops. Okay, it's called recursion.
Languages like Lisp.
Yeah, Lisp and Prolog, that sort of weird languages. But they do exist.
They're not weird, they're interesting.
Well, they exist to solve very specific problems.
Right.
Yep.
I was just wondering, in the first line of the code that you wrote, well, I noticed in your notes you don't have it, but when you were typing it up, you did the parentheses. Do you consider that necessary, or was that just to keep
In this
it
class,
neat
it
and
is
nice?
not.
Okay.
That's a good question. In this class, the parentheses are optional,
Okay.
because it's in this class I just added for clarity purposes to separate the condition from the other part of the syntax. But in C, the parentheses are mandatory. You have to use parentheses around the condition because that's how the syntax specifies a conditional statement. So that's also a very good question because eventually all of you will be programming in C and C++. So in that case, the parentheses are necessary. It is a mandatory requirement. All right. Well, before we go any further, let's trace the algorithm, okay? Because I think we did one trace with a conditional statement before, but we'll just go ahead and do it again, just so that we make sure that we all understand how to do this. And also, this is a good chance for me to kind of illustrate how to use LibreOffice Calc to work on traces of an algorithm. So we have if x is greater than y, I'm going to use exactly the same code here. Z gets a value of, do you see how Z got capitalized? Because I forgot to turn off some of the autocorrect options. So it's time to do it now. Go to Tools, Autocorrect Options, go to Options, turn off everything except for the first one, because I need the first one to make that left arrow. So Z gets the value of x in this case, else Z gets the value of y, and if, and without explaining why I'm doing the indentation, I'm doing it, okay? Yep, go ahead.
Are you running this LibreOffice off of a thumb drive?
Yes. I'm running the entire operating system, Google Chrome, LibreOffice, and everything out of my thumb drive.
Was that just something you forgot to check off before you used it in class, or does it not save anything?
Oh, I'm running it without using persistence, and that's why the saved option did not stick this time. Yeah. Okay. So this is the algorithm, and I'm going to label the line number here. And once again, the row number and the line numbers are the same, but I like to use a column just for the line numbers. And then we use a new window for the trace itself, just so that we can track down which lines will execute and how they will update the value of the variables. Now, every algorithm that has conditions, we want to use a column called comments, because this way I can capture something that cannot be captured by the other columns. We have line number, we have the three variables, we've got x, y, and z, and the variables obviously do not need that much space. We'll go ahead and control that. Line number probably doesn't need that much space either. Okay, so there we go. The first line in the trace is always pre, which is a precondition. In the previous examples, we have question marks for all the variables, which means I don't know the initial value of the variables. In this case, I do need to make some assumption, because otherwise I cannot proceed with the algorithm. So in the first case here, let's assume x starts with a value of 5, and y starts with a value of 9. And z doesn't really matter, so I would still say that z has an unknown value. It has a value, I just don't know what it is. and then we start execution on line 1. After line 1, what do you think will be the value of x?
Same.
Same, because line 1 does not change the value of x, y, or z. So if I were to be tedious, I would type 5, 9, and a question mark here. But from now on, because I'm lazy, I'm just going to leave it blank. If I leave a cell blank, it simply means the value of the corresponding variable is not changed. So that can save you a lot of time, because otherwise you'll be replicating and copying values all day long. But this will just be saying, oh, line 1 is not going to change the value of any of our 3 variables here. But it does have one thing to do, and that's why we need this comment column here. Because I want to indicate the result of the comparison. X is greater than y is true or false?
False.
It's false. Very good. It is false. So then where do we go?
Line 4.
We go to line 4. Exactly. Okay. Even though some people may think, oh, but we go to the else case, so why don't we say line 3? Well, I don't track line 3 because line 3 actually doesn't do anything. And if a line does not do anything, I don't put it into the trace, okay, because it's meaningless to include that here. And in some cases, it can be confusing. So in this case, I'm not tracking line 3, I'm tracking only line 4. Line 4 is an assignment statement, so it's going to do something to one of the variables. Does it do anything to x? Does it do anything to y? Does it do anything to z? And z becomes what? 9. Very good. And that is the end of the else branch. Now, the else branch can be very long, but in this case, it's very short. It only has one assignment statement. When we are done with one branch, we merge the 2 paths, and then we exit, get out of the conditional statement. So what should we put here at this cell? Post. Exactly. Post. Not line 5. Okay. As much as I want to emphasize, we are all done with the conditional statement, I'm not going to trace line 5. Now, there's a reason why I'm not tracing the end of a particular construct. Not only is it tedious and also redundant because it doesn't do anything, but when we get to loops, it is confusing when we trace and while. Okay, so we'll explain that when we get to loops. But it's post here because we are all done. So the end result is, yep, in fact, z has the maximum of these 2 particular values. So that's how we trace a conditional statement. And as you can see, this only works for a specific case of values, a certain value in x and a certain value in y. Let's try to do this again in another sheet. And this time we'll change the initial values. So I'll just copy the columns here into a new sheet. Get rid of the trace, change the values to, let's say, 4 and 1. Okay? All right, so that's the precondition. It is given to you that x starts with a value of 4, y starts with a value of 1, z is unknown. Okay, that's what the precondition is for. And then we start executing the algorithm. Line 1, once again, does not change the value of any of the variables, so there's nothing that I need to do with these 3 cells. But the other part is I have to indicate the result of the comparison. X is greater than y is true. Okay, so we have to indicate that. And because the condition is true, where do we go next? We continue execution with line 2. And as a result of executing line 2, z is going to get a new value of 4. And then we're done. Post. Remember, we only take one of the 2 branches. Okay, when you're done with one branch, it's time to get out of the entire conditional statement. Are we doing okay so far? So here's a question that I'm not really ready to answer at this point, but we will answer that question eventually. How do I know the algorithm that is on the left-hand side is correct? Now, so far, I know it is correct in these 2 test cases, right? We tested it with x, with 5 as the initial value of x and then 9 as the initial value of y, and the result is correct. We tested it again with different values. X started with a value of 4, Y started with a value of 1, and the result was correct as well. How do I know this is going to work regardless of the value of X and Y? It's always right. Do you understand the question?
You may need to do a proof.
Maybe to do a proof. All right, so you're definitely getting it. Okay, I can throw as many values as I want to this algorithm, but it doesn't guarantee the next test case is still going to be correct. Okay, are we doing okay? Yep, go ahead.
So what if the only time it's wrong when they're both the same?
See?
When X and Y value is the same, when that be wrong? That means
No,
you
it won't
choose
be
one
wrong.
side or the other, but it's still not greater than.
But it's still the maximum. What is the maximum of 3 and 3?
3.
It's 3, which is also the minimum because you only have one unique value in that case. So the algorithm will still do the right thing and makes Z the maximum value. So it will still be correct in that case. Okay, because the algorithm is only supposed to find the maximum of the two variables and then update Z with that maximum. So when X and Y are the same, it will choose the else path, it will choose line 4, but the result of the execution of the algorithm is still correct because you will still be finding the correct maximum of the two. Okay. But what I'm trying to point out is you can throw as many darts as you want. So even though, when you look at the landing spot of each dart, it is correct, there's no telling that the next dart will still be correct. The next test case will still be right. Okay? And that's the problem with trying to prove an algorithm is correct using test cases like this. Because there's no telling. I mean, you can construct 20,000 test cases that work just fine with an algorithm. But you know what? The next one can prove it wrong, can prove the algorithm is incorrect. Okay? This algorithm is actually correct, so I cannot prove it is not correct. Okay? But there are cases where it's tricky to prove an algorithm is incorrect, and I think we have time today to get into one of those cases. If you're really interested in proving your algorithm to be correct, regardless of the initial condition, you have to prove it like in mathematics. Prove it. Okay. We will eventually get to that part, and for those of you who really want to read ahead of time because, I really want to know how to do that, you can just go ahead and read where is it? Topic 4. It only has one link, which is called pre and post conditions, and that turns out to be a pretty big topic. A lot of people do not like this because it has a lot of math. Okay, this one is math. It's not arithmetic. It's not about doing calculations. It's about mathematics because it's about proving an algorithm being correct. So that's something that we'll talk about in topic 4. But for the time being, we're going to go back to topic 2, and we'll try to finish up this topic. All right.
One last question.
Go ahead.
In terms of the example we're looking at, when we're passing through this argument here, and we make the change to pass the value of z to x or z to y, or x to y, z to y, I'm sorry. Is it Is it doing like a copy or a reference in terms of actual placeholder value?
It is just these are assignment statements, and an assignment statement has 2 steps. One, evaluate the right-hand side, and then it updates the left-hand side, right? So in this case, the right-hand side is very simple. It is an expression, but the expression only involves the value of y. So that becomes the right-hand side value. And because it's an assignment operation, I update the left-hand side with that value. So it really is a simple copying of value. Okay. All right, so that part is done. Now we talk about logical operators. Okay. The necessity of a logical operator is sometimes it is handy to be able to combine the result of multiple conditions in order to form a more complex condition. Okay. So we'll go ahead and look at this new problem here. The new problem is presented here. We want to think about the logic. We want to come up with an algorithm so that we are given 3 variables in this case. W, X, and Y are given to you, and I want to find the maximum of Z in this case. Okay? So I just extended the original problem a little bit. Instead of 2 variables, now we have 3, and I have to find the maximum of the 3. Now, since we already know the concept of a conditional statement, we can use a template like this. If C1, C subscript 1 is representing a particular condition, which at this point is not, we haven't figured out what it is yet. But whenever that condition is true, it indicates that W is the maximum of the 3. So I'm going to update Z using the value of W. If that is not the case, if C1 is false, then we'll evaluate C2, the second condition. If the second condition is true, it means X is the maximum, and then in that case, I'll use X to update Z. If the maximum is not W and it is not X, since I only have 3 variables, it has to be Y. So that's why in the very last case, I use Y to update the value of Z. The question now is, how do I express C1? Let's just focus on C1 here and say, from one condition, I can confirm that W is the maximum of the 3. Okay? This is one expression. Okay, I should say one expression. It can involve multiple comparisons, but the comparisons will have to be connected by a logical operator. Okay? So how do you know, how can you tell that W is the maximum of the 3 variables? One comparison is only good for comparing 2 variables. Go ahead.
I was going to say, if W is greater than X and W is greater than Y, then W should be passed on to Z.
Yes. Okay. Well, sort of. Very close. Whether you use greater than or equal to actually has an implication. So we'll talk about that later because I want to use that to illustrate the fact that you can have an algorithm that works in most cases, but you can throw certain cases in it and then it will just mess up. Okay. So we'll talk about that later. Okay. So, but you're absolutely correct. What we need are these operators. I use the mathematical name of those operators. A conjunction is basically the word and in English. Okay. A conjunction is an operator that has 2 sides. Okay, just like addition, multiplication, division. It takes 2 things and then they give you a single result from the operation. The entire conjunction expression is true if and only if both sides are true. Okay. In English, a conjunction is basically known as and. The mathematical symbol of a conjunction looks like a little TP without the bottom, or an inverted V if you want. In C and other C-derived language, the conjunction operator is ampersand, ampersand. This is not a typo. Okay, it really is double ampersand. Okay, and this is a good time to briefly describe what happens when you use a single ampersand instead of double ampersand. A single ampersand is a bitwise AND operator in C and C++. So syntactically speaking, it is okay. But it doesn't mean exactly the same thing as a logical AND, which means sometimes your program will work correctly and other times it won't. And it's not a syntax error, so the compiler as a tool cannot help you with that. So you got to be careful when to use a single ampersand and when to use a double ampersand operator.
So it's okay to use set notation for certain operations as long as we're consistent?
Set operation?
This is when I look at that, it says union.
It's the other one. This is an intersection, but it's not a set operation. This is a logical operation. When you refer to a set operation, you're talking about one set with a certain group of values, and then you have another set of a different group of values, and then the intersection would be the region that is overlapping the two groups. So it's similar or related to the concept of an intersection, which is a U inverted, but this is a logical operation. It is not exactly the same as the intersection. Not the union. Union is the other one, is OR. Yep. Okay, but I can also define a conjunction like this. True and true is true. False and true is false. True and false is false. False and false is false. And that completely defines an operator that is a Boolean operator. B-O-O-L-E-A-N, Boolean, means an operator can only deal with values of true and false. For those of you who are curious, why is it called Boolean? How come it's not just called true, false value? Well,
George Boolean or something like that? It was something Boolean.
Yep, you just look up Boolean in Wikipedia, and it will tell you the mathematician called George Boole, and he is the guy who invented Boolean algebra, which forms the basis of a lot of the stuff that we use today in computer science. That's why all the expressions only involving true and false, those are called Boolean expressions. And the algebra, as a result, that deals with true, false values only, is called Boolean algebra. So all of this stuff is going to be important, in a as a computer scientist, you definitely need to understand all of this stuff here. Okay, that's conjunction, which is just the word and in English. The next one is a little bit more confusing. Disjunction is the word or in English, but not either or. Okay? Because or is what we call just a simple or. Either or is what we call exclusive or, which means it can only have one thing being true if for the entire thing to be true. But a regular or, which is what we have what we're describing here, is if at least one side of an or is true, the entire thing is true. Let's just take a look at the possible combinations here. True or true is true. False or true is true. True or false is true. The only time you can get false is when both sides of the operator are false. Then the outcome of the operator itself is also false. Are we doing okay so far with the disjunction operator? Yep.
Dumb question, but that's just a V, Not on the first keyboard-wise.
Keyboard-wise, it's just the V, but as far as this class is concerned, I'm just going to spell it out as or. In C and C++, it is known as the double bar. The bar symbol is shift backslash. Usually it's on top of the enter key. And once again, a single bar is a bitwise or, which works a little bit differently. Okay, it's not exactly the same as a logical or. This is a logical or. So when you get into a C class, just be careful when to use a double bar and when to use a single bar. Any questions about disjunction? Questions? Moving on to the last one, which is also a simple one. It is negation, which is a fancy word for the English word not. Okay. This one is easy to define because not true is false and not false is true. In this class, I'll just use the word not for negation. In C, it's the exclamation point to represent logical or. Bitwise or has a different symbol. It's the tilde symbol to represent bitwise or. All right. Are we doing okay so far with these logical operators? Yep.
What about NAND and NOR?
NAND and NOR are a combination. So, okay, since you asked the question, I just want to tell the rest of the class, you don't have to deal with this part here, but since you asked the question, I'm going to kind of explain that. X NAND Y is really the same thing as the negation of X and Y. So the NAND, the end of the NAND, is a negation that applies to the entire conjunction in this case.
I was wondering why it's not here, because in
semiconductors will have actually different gates for all of the logic gates.
That is true.
So
Yeah.
I don't know why. Yeah, you better get it.
Because it is equivalent. Because you can give me just negation and I can define all the other operators. So because it's equivalent and most people are used to the non-negative version of disjunction and conjunction, so that's why we talk about just that here. And it's also because in programming languages like C and C++, they only have and or defined. They don't have the NAND operator or the NOR operator. So there are particular reasons why we don't use those operators.
It's just useless. Why?
Well, they don't give us any particular value in this class. Now, I understand what you're talking about in semiconductor, in gate logic. Sometimes they only give you NOR gates, other times they only give you NAND gates, and you have to use those gates to recreate all the other logical operators. So you're definitely right in that case. But this class is a little bit not quite at that level. So we are not going to use the negative version of and or because it does throw a wrench into how people understand the logic.
But it's there, right?
Oh yeah. You can define your own operator too. I mean, there are. All right. So are there any questions about this discussion here? The three operators that we need are conjunction and disjunction or and negation not. Okay. Do we use those in daily on a daily basis? If you read promotions and a lot of other things, they would, especially the fine prints, they will give you expressions like that, so you have to fulfill like this requirement and that requirement and that requirement, or you can also get the same promotion if you are da 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 and so on. So we do use these words in these for these particular meanings in daily life. All right. So now that we have talked about conjunction and disjunction, I think we are ready to tackle this problem. So what I'll do is I'm going to use a new spreadsheet to express the algorithm. So this time we have 3 variables and we want to find the maximum of the 3. Now this is not the only way to do it, but it is one way to do it. Okay, so we'll just kind of pause here whenever I finish one line here. If W is greater than or equal to X and W is greater than or equal to Y, I think it's okay to use W as the maximum of the 3. Is that making any sense? Mm-hmm. Okay. So the action associated with this condition is Z gets the value of W. Okay. So let's say this condition is not true. Okay, it is not true that W is greater than or equal to X and W is greater than or equal to Y. Just to make this logic a little bit more uniform, I know there's a better way to do this, but I'm not going to do it that way. I'll just check X, but using the same format. If X is greater than or equal to W, and X is greater than or equal to Y, then if these two conditions are both true at the same time, I think X is the maximum of the 3. Is that okay? Yep.
Well, we already checked X against W in the first line.
Yep. That's why I said this is actually redundant.
Yeah.
But I'm just going to use the same format, because it's just utilizing the same reasoning in the process.
Right.
But you're absolutely right. I'm doing one extra comparison that does not need to be done. Z gets X. What if this conjunction is not true and this conjunction is not true?
Then Y is?
Then whatever the third one has to be, the maximum. So Z gets Y and if. All right. This particular algorithm is a little bit tricky to understand or to follow. The tricky part has to do with, is it important to evaluate the condition on line 1 first and then the one on line 3, or can I flip the order? That would be the question. So in order to answer the question, we want to look at the pictorial representation of something that looks like this. This is what I call a multi-branch conditional statement because it's no longer limited to 2 branches. This time we have 3 branches. The 3 branches are represented by line 2, line 4, and line 6 here. So we got 3 branches in this case. It's no longer 2, and that's why I just call this multi-branch conditional statement because it can extend to as many branches as you want. Okay. All right. So what I'll do is I'm going to give you a general template first, and then we'll draw a picture for that template. So the template says, if C1, then S1 for statement 1, else if C2, S2 for statement 2, else S3 for statement 3, and if. This is the template. I'm going to draw a picture representing that logic. So we'll take this one over here, and then go back to this guy here, and we'll just go ahead and make a new document. And draw our picture. I do want to show this one on the side. So this way we can keep an eye on the algorithm that we are trying to represent here. This is a multi-branch conditional statement. Okay. So it looks kind of like the other one, at least up to this point. So up to this point, it looks like 1/2 of a typical conditional statement. But the other side is interesting because the other side has another branch. So a multi-branch conditional statement, especially the one that we are dealing with right now, the other side, let me just extend it out a little bit more, is a branch itself. So it has its own 2 options. I know the picture is not showing very well now. Don't worry too much, it's all in the notes. I'm just all right. So this is the general picture of a multi-branch conditional statement. It has got 3 branches. So I'm going to label S1, S2, and S3 so that we know, which label or how we're going to label this. So we'll call this S1. This is S2. Oops. And this is S3. Okay. So it looks like we have to first make a decision to whether we are executing S1 or not. Which condition do you think will help us decide whether we want to execute S1 or not? Then condition
C1.
C1. Okay, very good. So I would put C1 over here. This time we have a transparent rectangle. Why is it transparent this time? And it's not giving me the option to, okay. We don't want fill, we want to do that. There we go. All right. So this is the first condition to evaluate, and it is labeled C1 in the pseudocode. And here we have the second condition to evaluate because we have a second branch here, and it is labeled C2. That is the picture. This is the picture representing this logic here. So according to this picture here, can I interchange the order of evaluating C1 and C2? Nope. You always evaluate C1, If C1 evaluates to false, then you evaluate C2. Okay? So to make this picture more complete, I'm going to label the branches, which indicates when we go to each branch. This is the branch that we take when C1 is true. If C1 is false, we take the other branch. But the other branch takes us to another branch, to another fork. So that means I have another choice of going to the true branch and versus going to the false branch. So that would be the complete picture of a multi-branch conditional statement involving 3 branches. Are we doing okay so far? Is that okay?
Yeah.
Okay, so I'm going to keep this up when we work on the trace of the algorithm that we are doing. Okay, so this is the algorithm that we are dealing with now, and I'm going to trace it in sheet 2. So we have comments because we have conditions to evaluate. We have line number, and then this time we have 4 variables. We have W, X, Y, Z. Let's deal with the complicated case first. Okay? Let's deal with the complicated case of what happens when W, X, and Y are exactly the same. Okay, so they all have the same value of 3. Z is only there to store the maximum, so it doesn't have to have a particular value to start with. And this is my precondition. All right, let's go ahead and start with line 1. Line 1 is a little bit longer now, a little bit wider. So I think I need more space, or change the zoom. I'm going to change the zoom here. There we go. Okay, everything fits again. So we execute line 1. What do you think is the result of line 1? W is greater than or equal to X, and W is greater than or equal to Y. Is that true or false?
True.
Okay, so I have to type out the whole thing. This is true. And where will that bring us? The condition is true here. Let's take a look at the picture. C1 is true. Where do we go? We go to S1, and back to the pseudocode here. What is our S1? Which line is our S1?
Line 2.
Line 2. Okay, so that means we proceed to line 2, and line 2 is going to copy the value of W to Z. So Z gets the same value as W, which is 3. And then where do we go? Post. Very good. Even though it is very tempting to look at line 3 and go, but that's true too, because all three variables are exactly the same. So why don't we evaluate line 3, look at line 3, and then say that condition is true too, and then we execute line 4. Well, if you just look at the pseudocode, you might be tempted to do that. But if you look at the pictorial representation of the same logic, then you know after S1, you don't get a chance to execute or go to the other side. After S1, you go all the way to the exit of the multi-branch conditional statement. Okay? So that's why we don't deal with C2 once C1 is true. So that's why the ordering is important. Are we doing okay so far? I have enough time to mess up my algorithm, but in a weird way, okay? I'm going to mess this up a little bit, and I'm just thinking whether I should do this here or not. Yeah, I'll just do it here. Okay. So the way I mess up this algorithm is simply to remove all of the equal of greater than or equal to. That's all. Which at first glance doesn't seem to make any difference. I mean, if W is greater than X and W is greater than Y, W is still the maximum of the 3, right? If X is greater than W and X is greater than Y, X still has to be the maximum of the 3. No problem. If W is not the maximum and X is not the maximum, then it has to be Y. So following this logic, it seems like the equal symbol doesn't seem to make any impact in the algorithm. Okay, so you can throw tons of test cases to this thing here, and not realize there's a problem. As long as the test cases that you're throwing have 3 distinct values, the bug won't show up. The bug will only show up when you have the same value in only 2 of the 3 variables, and that's the maximum. Then it will figure out the wrong thing, sometimes, depending on which 2 has the same value. Okay? Okay. Without actually, asking you guys to do it for me, let me just do it here so I can illustrate. By the way, once I change the algorithm, this path here, this execution path, will be wrong because it won't, it's not going to execute line 2 anymore. Okay, keep that in mind. Okay, now let's go ahead and start another test case. So we have just copying and pasting the columns, so I don't have to redo that part. And our precondition is going to be 5, 5, and 2. And then we have unknown here. Okay? Pretty sure some of you are already seeing, this is going to the wrong place. Let's take a look. Starting with line 1. Line 1 evaluates the condition x is greater than, w is greater than x. Is that true or not?
False.
That is false, okay? And at this point, we're going to go through this, even though I can make the conclusion that the whole thing has to be false, I'm not going to go through the whole thing anyway, because we have not talked about short-circuited evaluation. What about w is greater than y? That's true. So now we have false and true. What is the result of false and true?
False.
False, okay? Because with conjunction, if at least one side is false, the entire thing is false. So in this case, we have one side being false, the entire thing is false. According to this picture, let me go back to the picture here. If this condition is false, we follow this branch here. Now we can evaluate the second condition. Great. So now we look at the second condition, which is on line 3. So the next line to execute is line 3. Line 3 has a conjunction that looks about the same, but not exactly. The first comparison is between x and w. X is greater than w is false. And then the second one is comparing x to y, which is true. False and true, once again, is false. Okay. Looking at the picture here, we just evaluated C2. It is false. So we're going to have to execute statement 3, S3. Statement 3 in our existing pseudocode corresponds to line 6. So that's where we go, line 6.
2 is the greatest value. 2 is the greatest value.
Yes. So now z is going to get the value of y, which is 2, and we are done with this algorithm. It's not obvious, is it? And it will the problem only shows up when you have w and x containing the maximum and y containing some value that is less. Okay? If you choose any other test cases, it will work just fine. So that means, if you do not choose your test cases correctly, you can be throwing tens of thousands, hundreds of thousands, millions of test cases at this thing, and it will still say it's right, it is correct. On the other hand, if you try to prove its correctness, then you will end up with a post-condition of the entire thing that is not correct. Okay, so that's why topic 4 in the notes is important, because even though practically speaking we don't do anything like that, because if I go back to my notes here, if I go just do a little fast forward to topic 4, in fact, since we only have a minute and a half left, what I'll do is I'm going to show you a little bit of this. It's a little preview. And this is the first section of this topic. What is this crazy math? Okay? Not that I want people to drop from the class, but there is a lot of math involved when you want to formally and rigidly prove an algorithm is correct. Okay, and there's no way around it. There's no way around it when you want to prove the correctness of an algorithm. And it also does not help to say that in a lot of universities, the computer science department was originally a spin-off from math, okay, from mathematics. Okay? In some other universities, it's a spin-off from engineering. So it depends on which one you go to. Sometimes it has a very heavy spin in terms of math. Are there any questions? We only have about 20 seconds left. Yep. I thought the roll sheet was being passed around. I did not pass it. Okay, so make sure you fill it in. I'm sorry about that. Do you guys want me to? Well, let's just pass it this time. Next time I'll pass it in the middle of the class. I was tempted to ask, those who are missing, raise your hand. Then I can just cross out those. But somehow the logic just doesn't work out there.
So why not have